Okay, today's video is covering circle theorems, Pythagoras theorem, and trial and improvement. There are two links to YouTube videos there. Those are about circle theorems, so you might want to look at those first to remind yourself of the different theorems. When you've done that, come back to this and we'll go through some exam questions. Okay, so here's an exam question. It says O is the center of the circle. ABC is a straight line, so that's ABC, that's a straight line. Angle CBD is 118 degrees, so CBD with B in the middle, that's 118 degrees. So immediately we spot angles on a straight line, and they've got to add up to 180, so 180 minus 18 is 62. So that's 62. Now we've got the circle theorem about angles at the center being twice the angle at the circumference. So that's when you've got 2 points, and from the 2 points you make an angle at the center, which is x, and from the same 2 points an angle to a point on the circumference of the circle, the edge of the circle, and that's 62. So the x is twice the 62, so it must be 114. No, not, sorry, 124. Get the eraser. 124. Okay, so we need to write a little bit. ABD was 180 minus 118, which was 62. Angles on a straight line. AOD is 62 times 2 equals 124. Angle at center. If I had more space, I'd write more. But the answer is 124 degrees. Okay, then it says P is a point on the minor arc AD. So AD, the arc of a circle is a part of the circumference of a circle. So you've got the big arc, the major arc, and the small arc, the minor arc. So A round to P and D. P is a point on the minor arc AD. Explain why angle APD is 118 degrees. So angle APD is the angle if you draw a straight line from A to P, and then another one to D. APD, explain why that angle is 118 degrees. Well, the reason for that is that it forms a cyclic quadrilateral, a four-sided shape, A, B, D, P, where all the four sides are on the circumference of the circle. And when you have a cyclic quadrilateral, the opposite sides add up to 180. So 62 plus 118 makes 180. So our explanation is because A, B, D, P is a cyclic quadrilateral, so APD, angle APD equals 180 degrees minus 62 degrees, which is 118 degrees. I don't particularly like that I've got two equal signs on the same line, but we haven't been given much space. Okay, our next circle theorem question is from November 2012. It says the diagram shows a circle, centre O, ATB is a tangent at T. As soon as you see a tangent to a circle, you're thinking of a couple of things. You're thinking that a tangent meets a circumference at 90 degrees. Sorry, a tangent meets a radius at 90 degrees. And you're thinking the alternate segment theorem might be in there somewhere. But let's have a look at it. It says work out the value of x. Well, we've got the circle theorem about the angle at the centre being twice the angle at the circumference. So these two x's add up to half of 124. So let's write 2x equals 62, i.e. 124 divided by 2. So 1x must be 31. So that each of these is 31, adding up to 62, which is half of the 124, because the angle at the centre is twice the angle at the circumference when they both come from the same 2 points. So answer 31 degrees. Work out the value of y. Okay, well it's not an alternate segment theorem. What we've got here is an isosceles triangle. OTE is formed from the radius of the circle here, OE, and then OT is also the radius of the circle. So those two sides are the same, and these two angles are the same, 31 and 31. So I'm going to write OET triangle is isosceles so angle OTE angle is 31 degrees, and then because tangents meet the radius of the circle at 90 degrees, you've got 90 degrees in here formed by the 31 and the y. So OTA angle, there's a couple of different ways of denoting angle. An angle sign in front of the letters, or I actually prefer a little hat on top of the thing that's the angle. So angle OTA equals 90 degrees. Tangent meets radius. So y has got to be 90 minus 31. Y is 90 minus 31, which is 59 degrees. I don't need to put the degree sign actually because it already says degrees there. But y is 59 degrees. Okay, here's our final circle theorem question for today. The diagram shows a circle, centre O. Work out the value of x. Well, this looks familiar. It's 2 points, and the angle at the centre is twice the angle at the circumference from the same 2 points. So the angle x is 140 divided by 2. I'll use a slash for divide, which is 70 degrees. 1 mark for that, so that's enough. I don't need to write the reason, although I guess I do need to write the working. Now, just to get this in focus, I'll move this up a bit. The diagram shows a cyclic quadrilateral. So what we know about cyclic quadrilaterals is that opposite sides add up to 180. So 4y plus y equals 180 degrees. So in other words, 5y equals 180 degrees, and y must be 36 degrees. So y is 36 degrees, 4y is 4 times that, 144, and they add up to 180. And the question was to work out the value of y, so we've done that, 36 degrees. Okay, so on to questions about Pythagoras. Work out length AB as a decimal. Now, as soon as you see a right-angled triangle, you should be thinking that it's probably either Pythagoras or trigonometry. And because there's no angles in this question, it's going to be Pythagoras. So AB squared equals 9 squared plus 7 squared. So the square on the hypotenuse is equal to the sum of the other two squares. The two smallest ones squared, added up, make the biggest one squared. AB squared equals 9 squared plus 7 squared equals 81 plus 49, which is 130. So AB has got to be the square root of 130. So we need to work that out as a decimal, and it's it's going to be 11 point something. You can work that out. I haven't got my calculator handy. 11 point something. Okay, so I've got my calculator now, and the next question is from November 2012. We've got a right-angled triangle. It's hidden within something else. But again, as soon as we see the right-angled triangle, we're thinking Pythagoras or maybe trigonometry. This is Pythagoras because there's no angles involved. Work out the length of the diagonal. So the diagonal squared equals 30 squared plus 35 squared, because there's a right-angled triangle there with the diagonal being the hypotenuse. 30 squared is 900, and 35 squared is 1225. So they add up to 2125. So the diagonal squared is 2125. So the diagonal itself is the square root of 2125. 2125 square root is 46, round that to 0.1, 46.1 centimeters. Now the next part of the question is trickier because it's in 3 dimensions, but it contains a lot of right-angled triangles within the 3-dimensional situation. So you've got to try and visualize the 2-dimensional triangles in the 3D box. So we've got the base of a box, 30 times 35, and we should recognize that as something we've seen from the previous part of the question. So just looking back at that again, the diagonal that we worked out was 46.1 because that was the square root of 2125. So for my own benefit, I might want to write in that that's square root of 2125 equals 46.1. The height of this box is 87, so that's 87 there, as well as there and there and there. And inside the box we've got a right-angled triangle. It doesn't look like a right-angled triangle because we're looking at it from a funny angle, but from here to here to here is a two-dimensional right-angled triangle. So the diagonal in the box from there to there, that squared equals 87 squared plus 46.1 squared. So we're applying Pythagoras' theorem to this triangle here. The two short sides squared add up to the square of the big side. Diagonal squared equals 87 squared plus 46.1 squared. 87 squared, 87 times itself is 7569. The 46.1 squared, we know that that's 2125 because we used 2125 already. So the 7569 plus the 2125 add up to 9694. So the diagonal squared is 9694. So the diagonal itself is the square root of that, which is 98 point, I'll round that to 46 centimeters. So the question is, will a straight rod of length 1 meter fit in the box? No. A 1 meter rod will not fit. No, a 1 meter rod will not fit because the diagonal is only 98.46 centimeters. Okay, final question on Pythagoras from a recent paper. Work out the length of AC, very straightforward. AC squared equals 13 squared plus 6.5 squared. Got to remember to use the English dot for a decimal actually. 13 squared is 169. 6.5 squared, I'll just get my calculator for that, times itself is 42.25. So add those up. 211.25 is AC squared. So AC must be the square root of 211.25, and that's 14 point, I'll round my answer to 5. Must remember the dot for a decimal. 14.5 centimeters. Now, a new topic. A question that sometimes comes up asks you to solve something by trial and improvement. So they've started you off. Use trial and improvement to find a solution to x cubed minus 20 equals 60. So they've said, okay, what if x was 5? Then the thing we're working out, the x cubed minus 20x, so that would be 125 minus 100 would be 25, and that's too small because we want the answer to be 60. So I'm going to say, okay, try a bit more. What if x was 8? So if x was 8, then we'd have 8 cubed, 8 times 8 times 8, 512. minus 20 times 8, 20 times 160, so 20 minus 100, start again, 20 times 8 is 160, so x cubed minus 20x would be 512 minus 160, 352. Now 352 is way too big if we're aiming at 60. Comment, too big. So we'll try somewhere in between. How about 6? Okay, so 6 times 6 times 6 is 216, and 20 times 6 is 120. So x cubed minus 20x, if x is 6, that will be 216 minus 120. I shouldn't need my calculator for this, but it's very early in the morning. 96. And that's too big still if we're aiming at 60. So we know that the solution, or a solution for x, there may be more than one, lies between 5 and 6, because 5 gives you something that's too small and 6 gives you something that's too big. So try 5.5. So if x is 5.5, 5.5 cubed, I've got a button for it there, is 166.375. 20 times 5.5 is 110. So x cubed minus 20x would be 166.375 minus 110, 56.375, which is still a little bit too small. So if 5.5 gives you something that's too small and 6 gives you something that's too big, the answer must be somewhere in between. So let's try 5.7. So 5.7 cubed is 185.193. 20 times 5.7 is 114. So if x is 5.7, then the whole thing will come to 171.193. No, it won't. Sorry, 71.193. That's still too big. So 5.5 gives you something that's too small. 5.7 gives you something that's too big. Obvious thing now is to try 5.6. So 5.6 cubed is 175.616. 20 times 5.6 is 112. So if x is 5.6, the whole thing, x cubed minus 20x, comes to 63.616, which is too big. So we're trying to get the answer correct to one decimal place, and we know that 5.5 gives you something that's too small, and 5.6 gives you something that's too big. So we need to just go to the second decimal place to be sure of the answer to the first decimal place. So we'll go between 5.5 and 5.6. We'll go 5.55. If x is 5.55, then x cubed is 170.953875. And 20 times x, 20 times 5.55 is 111. So if x is 5.55, then the thing we get is 59.953 something, we're not interested really anymore, which is too small. So 5.55 gives you something that's too small. 5.6 gives you something that's too big. So to one decimal place, the correct answer is closest to 5.6. But it's important that we go to that second decimal place to be sure whether the correct answer is nearer to 5.5 or 5.6. It's not correct to try and look at these numbers and figure out which one's nearer to 60. You have to go to the second decimal place with the x to be sure of the x to the first decimal place. Okay, tomorrow we will look at some questions on vectors and trigonometry.